laws of motion, let's start with force. Force is a push or pull which changes or tends to change the state of rest or of uniform motion, size, or shape of a body. Its SI unit is Newton, and its dimensional formula is mLT minus 2. Forces can be categorized into two types: contact force and action at a distance force. Contact forces include frictional force, tensional force, spring force, normal force, etc. Whereas action at a distance force include electrostatic force, gravitational force, magnetic force, etc. Now, let's know about inertia. Inertia, the property of an object by virtue of which it cannot change its state of rest or of uniform motion along a straight line on its own, is called inertia. Inertia is a measure of mass of a body. Greater the mass of a body, greater will be in its inertia, or vice versa. Inertia is divided into three types: inertia of rest, inertia of motion, and inertia of direction. Inertia of rest, where we can learn inertia of rest with an example. When a bus or a train starts to move suddenly, the passenger sitting in it falls backward due to inertia of rest. Whereas inertia of motion can be described as when a moving bus or a train stops suddenly, the passengers sitting in it jerk in the forward direction due to inertia of motion. Inertia of direction. We can protect ourselves from rain by using umbrella because raindrops cannot change its direction on its own due to inertia of direction. Now let's begin with Newton's laws of motion. First law. If the according to Newton's first law of motion, every body continues to be in its state of rest or of uniform motion in a straight line unless it is compelled by some external force to act otherwise. If the net external force of a body is zero, then the acceleration will also be zero. Acceleration can be non-zero only if there is a net external force on the body. The first equation of motion is V is equals to U plus AT. We can understand more about this law by an example. So, a body of 5 kg mass is moving with a velocity of 20 meters per second square if the force of 100 Newton is applied on it for 10 seconds in the same direction as the velocity, what will be the velocity of the body? For this, we will have to find the acceleration first. So, F is equals to ma. So, force 100 is equals to mass 5 kg is equals to A. Therefore, A is equals to 100 by 5. A is equals to 20 meters per second square. On substituting the value in the new of by by substituting the values on in the Newton's first law of motion, we receive 20 plus 200 is equals to 220 meters per second square. So the velocity of the body will be 20 meters per second. Before moving on to the second law, we should understand what is momentum. So the momentum P is defined as the product of its mass m and velocity v, that is P is equals to m into v. Second law. Now let's begin with the second law of motion. According to Newton's second law of motion, the rate of change of linear momentum is proportional to the applied force, and change of momentum takes place in the direction of the applied force. Mathematically, force is equals to K d upon dt. That is K m a, where m is constant, F is the net external force, applicable to a particle, body or a system of particles, provided F is the total external force of the system, A is the acceleration of the system as a whole. Newton's third law of motion. For every action, there is equal and opposite reaction. Action and reaction forces are simultaneous forces. There is no cause-effect relation between action and reaction. Any of the two mutual forces can be called action and the other reaction. Action and reaction act on different bodies and they cannot be cancelled out. Mathematically, is equals to minus F21. One of the most common examples of Newton's third laws of motion will be swimming, jumping of a man from a boat onto the bank of a river, pulling of a cart by horse, etc. Example of application of Newton's third law of motion uh, can be explained by an example. A car moving with a velocity of 10 meters per second can be stopped with the application of constant force F in a distance of 20 meters. If the velocity of car is 30 meters per second, it can be stopped with a force. Here, final velocity is zero and final velocity is zero and acceleration is negative. Therefore, v square is equals to u square minus 2as, that is 0, is equals to u square minus 2as. 2as is equals to u square. S is equals to u square by 2a. Therefore, S is proportional to u square. The car moving with the velocity of 10 meters can be stopped by the application of a constant force F in a distance of 20 meters. Since the velocity is tripled, stopping distance will become 3 square is equals to 9 times. Therefore, the new stopping distance will be 9 into 120, that is 180 meters. Note, Newton's second law of motion is called real law of motion because first and third laws of motion can be obtained by it. Non-inertial frame of reference. A frame of reference non-inertial frame of reference a frame of reference having an acceleration with respect to an inertial frame of reference is called non-inertial frame of reference. Newton's first and third laws of motion are not applicable in the non-inertial frame of reference. We can use their acceleration of a non-inertial frame with respect to an inertial frame of reference. Impulse. Impulse is defined as the product of the force and time for which that force acts on a body with equal change in momentum. That is, impulse is equals to force into time duration is equals to change in momentum. So, suppose a force F acts for a short time dt, then the impulse will be F dt. Impulse is equals to area under graph. For a finite interval of time t1 to t2, then the impulse is equal t2 to t1, then the impulse is equals to t2 by t1 f dt. If constant force acts on an interval delta t, then the impulse will be f delta t. Therefore, f delta t is equals to delta p. Impulse is a vector quantity. Its direction and is same as that of the force. So, SI unit is Newton second and its CGS unit is dyne. Its dimension is same as momentum, that is m l t minus 1. In short, a large force acting for a short time to produce a finite change in momentum is known as impulsive force. Let's start with laws of conservation of momentum. Laws of conservation of momentum states that when no external force acts on a system, total linear momentum is one of the most fundamental law of mechanics. For example, recoil velocity of a gun is equals to V is equals to minus mv by m, where m is the mass of the bullet, big M is the mass of gun, v is the velocity of the bullet. Rocket propulsion is an example of variable mass. We can understand laws of conservation of momentum through various examples. One of them is a man weighing 80 kg is standing on a trolley weighing 320 kg. The trolley has frictionless horizontal rails available for its motion. If the man starts walking on the trolley along the rails at a speed of 1 meters per second, then calculate his displacement relative to the ground in 4 seconds. So, solution. Momentum is conserved. System consists of man and trolley. Therefore, the momentum of system is equals to momentum of the man. That is 320 plus 80V is equals to 80 into 1. V is equals to 0.2 meters. Displacement of a man is equals to 4 into 1 is equals to 4 meter. Displacement of the system will be if a block is moving on an inclined plane, we choose two directions along the plane and perpendicular to the plane. For example, if a block A block is released on a smooth inclined plane of inclination theta after how much time it reaches to the bottom of the plane. Therefore, this will be mg sine theta. This will be mg, and this will be mg cos theta. N is equals to mg cos theta. A is equals to g sine theta. Acceleration of the block along the plane will be g sine theta. Sine theta is equals to h by L is equals to L is equals to h by sine theta. Along a plane, A is equals to g sine theta. By substituting Newton's second law of motion, S is equals to ut plus half at square, we will get S is equals to u plus half g sine theta r square. H upon sine theta is equals to 0 plus half g sine theta r square. T is equals to 1 sine theta root 2h by g. Now let's start with spring. Combination of spring. First, series combination. The springs are said to be in series when the force in each spring is same but the change in length is different. The three, for example, let the three springs of force be K1, K2 and K3. Since springs are light, force in each spring is mg. Let x1, x2 and x3 be the extension of the strings. Therefore, x1 is equals to mg by k1, x2 is equals to mg by k2 and x3 is equals to mg by k3. Total extension is equals to x is equals to x1 plus x2 plus x3. Therefore, mg by k is equals to mg by k1 plus mg by k2 plus mg by k3. Therefore, 1 by k is equals to 1 by k1, 1 by k2 and 1 plus 1 by k3, where k total is an equivalent force constant. parallel combination. The springs are said to be in parallel when the change of length in each spring is same but the forces are different. The extension in each spring is same, therefore F1 therefore F1 is equals to K1x dot F2. F2 is equals to K2x. F3 is equals to K3x. F is equals to F1 plus F2 plus F3. Therefore, K equivalent x is equals to K1x plus K2x plus K3x. K is equals to K1 plus K2 plus K3. Hence proved. Sir,